Okay, so first of all, on page 44, you'll notice there's a table there of metric conversion factors. You do not need to memorize these. You're always going to have this table at your disposal for quizzes and assessments. All right, so the main thing is to just know how to use it, but it gives you the various metric relationships for mass, and the base unit for mass is grams, for volume, where the base unit is liters, for length, where the base unit is meters, and for time, where the base unit is seconds. Did you guys have any questions about the metric system before we proceed? Okay, I don't want to spend too much time on that because I think we're probably pretty solid. All right, so if you look up here, we're going to be solving conversion problems, and in order to do that, we need to be comfortable with the concept of a conversion factor. So a conversion factor is just an equality that relates two things with different units. So for example, it's a statement like 1 hour equals 60 minutes. And I'd love for you to write some of this down on page 44, just to kind of keep yourself engaged and on track here. And we know we can also flip that around and say that 60 minutes equals an hour, okay? So I think we all understand that 1 hour has the same value as 60 minutes, right? It's the same amount of time. It's just a different unit. Another example of this is 1 day equals 24 hours, or 24 hours equals 1 day. And if we want to talk metric stuff here, we can say 1 meter equals 1,000 centimeters, or 1,000 centimeters equals a meter. All right, so we can write these conversion factors as fractions, and this is what we're going to be doing in chemistry class most of the time. So for instance, this conversion factor up here of 1 hour equals 60 minutes, we can write it like a fraction here in that way, 1 hour over 60 minutes. And because they have the same value, because the top and the bottom have the same value, this fraction overall has a value of 1. You guys get that? Because anytime you have the same number on top and the same number on bottom for a fraction, the value of that fraction is 1. Okay? Similarly, if we flip it around, it still has a value of 1 because 60 minutes has the same value as 1 hour. The only difference between those numbers is the units. Put your hand up if you have a question, otherwise I'll keep on cruising here. Okay. Similarly, we can write this one as a fraction, 1 day over 24 hours, and it has a value of 1, and 24 hours over 1 day also has a value of 1. So since these fractions have a value of 1, we can multiply any number by these fractions, and it won't actually change the value. Because when you multiply something by 1, it doesn't change the value. And I'll give you an example of when you might do this. Let's say we wanted to convert 2 days to some number of hours. All right? Probably a lot of you could do that in your head pretty quickly. All right? But there's a procedure we can use for this. We can take our 2 days and we can multiply it by one of these conversion factors. And we're going to multiply it by the conversion factor that relates days to hours. And I'm going to put days on the bottom. So 1 days equals 24 hours. And what did we say we can do when we have the same unit on top and the bottom in a fraction multiplication? We can cancel it out. So this allows us to cancel out days. And we multiply 2 by 24, and we get 48 hours. Again, probably a lot of you can do that in your head, but this illustrates the procedure. You're definitely going to see some problems you can't do in your head. So keep in mind, when we do these, we're going to end up putting it in these train tracks. So that problem we just did, we'd have 2 days over 1 times 24 hours over 1 day. Same basic idea, but it would be in those train tracks that we're working with. Okay? So that's how you use a conversion factor to convert from one unit to another. All right, so here is an example of a problem where we would use this unit conversion procedure. So the question says, how many meters are in 2.9 kilometers? And we're now on page 45. If you didn't pick up on that, we're doing example 1. please follow along with me. How many meters are in 2.9 kilometers? So the first thing we need to do is read the question really carefully and identify the starting unit, that's the thing that you've been given, and the ending unit. So the thing that you've been given in this case is 2.9 kilometers, so that's going to be our starting unit. And our ending unit, that's our starting unit and number, and our ending unit is going to be meters. So you could think of it like this, where we're going from kilometers to meters. And you really got to read the question carefully and identify that correctly, because if you get that part of it wrong, you're kind of doomed for the rest of the problem. Any questions so far? All right. So the conversion factor, as we just discussed, is the thing that relates these two units to each other. So if you look on page 44 in the table, in the area for length, because we're talking about meters here, you will see that this is the relationship between meters and kilometers. 1,000 meters equals 1 kilometer. That'd be a good one to memorize, but you don't have to. It makes your life a little easier. So next, we're going to move down to this area here, which we call the train tracks. And this is where we're going to solve the problem and actually do the math here. So we are always going to put our starting number and unit down here in this upper left-hand corner box of the train tracks. So we're always going to do that throughout the whole year, every time these pop up. If it makes you feel more comfortable, you can put a 1 here in the denominator position. Don't really have to do that. And we're going to multiply by our fraction right here. Okay? So we're going to have either 1,000 over 1 or 1 over 1,000. It could be either of those. It depends on what we're trying to do. So what are we trying to do in this case? We're trying to cancel kilometers and convert to meters. So what do I want to put on the bottom of this fraction right here? I want to put kilometers on the bottom. And it's 1 kilometer. Sometimes people try to put 1,000 kilometers or something. And it's 1 kilometer equals 1,000 meters. Okay? And remember, this fraction here that I'm circling in red, this fraction has a value of 1, so I'm not actually changing any values here when it comes to my starting unit. The only thing I'm actually going to be changing is the unit. Okay? So because kilometers appears on top and on the bottom, it cancels out. That leaves us with meters as our unit, which is the goal. And now all we have to do is times on top and divide down. So if you're doing this in your calculator, you put 2.9 times 1,000. And if you want, you can say divided by 1, divided by 1. But that's not going to change the number at all. And our answer is going to be 2,900 meters. If you're comfortable with decimals, you know you didn't really have to use a calculator there because we have 2.9 times 1,000. And anytime you're multiplying a decimal by 1,000, all you have to do is move the decimal 3 places to the right, which is how we come up with the 2,900 there. If you were dividing by 1,000, you'd move it 3 places to the left. But if you're not comfortable with that, just use your calculator. That's fine also. Any questions? Raise your hand if you would like to see another example before you try. Would anyone like to see another example before you guys give it a try? Okay, give it a try then. I'll give you guys a couple minutes to do that. Okay, if I can get everyone looking up here again, we're back to go over the example 2 you try. Walk you guys through this. So step 1 is to read through the question carefully. Identify the starting unit. What is my starting number and unit for this one? What have you been given? 56 milligrams. The abbreviation for that is mg, if you look on page 44. And we are trying to figure out how many grams that is, so that is our ending unit. The relationship between these two is 1,000 milligrams equals 1 gram. And I got that again from page 44. Not something you have to memorize. So as always, I'm going to put my starting number and unit down here, 56 milligrams. I can put that over 1 as a placeholder. And I'm going to multiply by my conversion factor here, which has a value of 1. And which number goes on the bottom, 1 or 1,000?
1,000.
1,000 in this case. Beautiful. And that enables me to cancel milligrams and convert to grams. And so my answer is going to be in grams. And in this case, you can again plug it into the calculator, 56 times 1 divided by 1 divided by 1,000. Or you can just move the decimal 3 places to the left, 56 divided by 1,000, and you get 0.056 grams. Yes, sir?
Can we round it to 0.6?
Yeah, it's fine. Yep. Any questions about that one? So these two examples that we've looked at are one-step conversion problems because we multiplied by 1 conversion factor, but we are going to see 2 and eventually even 3-step problems. So I'm going to do one example of that with you guys now. So if you would skip ahead to example 4, this is a little bit trickier. So in this one, the question is, how many seconds are in 18.3 hours? So you've been given 18.3 hours. We're trying to convert that into seconds. So my starting number in the unit is 18.3 hours. My ending unit is seconds. So if we knew the relationship between those two, we could do this in one step. But you probably have not memorized that. So when we look on page 44, all we know is that 1 hour equals 60 minutes and 1 minute equals 60 seconds. So we're going to have to do this as a 2-step conversion. Okay, so we're going to need those 2 conversion factors that I just wrote down. First of all, 1 hour equals 60 minutes. That's going to be my first step, is to convert from hours to minutes. And then 1 minute equals 60 seconds. That's going to be my second step, is to convert from minutes to seconds. Give you a second to absorb that. Any questions? Okay. As always, I'm going to put my starting number in the unit in this upper left-hand box, 18.3 hours, put it over on 1. And my first conversion, we're going from hours to minutes. So what goes on the bottom here? Can somebody tell me? Hours, specifically 1 hour, equals 60 minutes. And that enables me to cancel hours. Now I've converted to minutes, so I'm just going to keep multiplying. Now I'm going to use this conversion factor to convert from minutes to seconds. And what goes on the bottom here of this? Minutes goes on bottom, 1 minute specifically, and 60 seconds on top. That enables me to now cancel out minutes, and it leaves me with units of seconds, which is the goal. So now we plug into the calculator 18.3 times 60 times 60. And if you want, divided by 1, divided by 1, divided by 1. But of course, that's not going to change the number. So has anyone done this yet?
65,880.
65,880 seconds. So we just figured out that 18.3 hours is the same as 65,880 seconds. So why don't you guys give the last example a try? It's the U try here. How many kilograms are in 251 centigrams? So how many kilograms are in 251 centigrams? So you've been given 251 centigrams. That's our starting number in unit, and we're trying to convert to kilograms. CG is the abbreviation for centigrams, and we're trying to go to kilograms. You'll notice when you look at page 44 that there is not a direct relationship between these two, so we have to do it in 2 steps. We have to go, first of all, from centigrams to grams, and that relationship is 100 centigrams equals 1 gram. And then we have to go from grams to kilograms, and that relationship is 1,000 grams equals 1 kilogram. And I got both those relationships again from page 44. You don't have to memorize those. So we put this down here in our starting number in unit place, 251 centigrams over 1. And step 1 is we're going to use this first conversion factor to convert from centigrams to grams. So what goes on the bottom? Centigrams. You guys seem to have this. Of course, that enables me to cancel centigrams. Then I'm going to use this other conversion factor to convert from grams to kilograms. What goes on the bottom? Grams. Nice. That enables me to cancel out grams and leaves me with units of kilograms. Can somebody tell me what you got on that one? I think it's a decimal, right?
0.00251.
And in this case, it's kind of hard to round that to the hundredths place. So if you just listed it like that, I'd be super happy. Okay. Anyone have any questions about that? All right. Again, there's going to be a video posted on the chemistry calendar. If you feel like you need to rewatch some of this, perhaps you nodded off during the explanations there for a while. You can come back and check it out. Let me know if you need any help. And let's complete the practice problems on pages 47 and 48, 49 and 50, 1 through 10.